Hey everyone, Smitty Halibut here. How you doing? Smitty working on something. Today I'm going to be working on an antenna. I've got a hankering to get a directional antenna up in the air above my house, hopefully above the electrical noise in my neighborhood, so that I can confirm whether it's worth putting up good money for a good beam directional antenna. I'm just looking for something right now to test to make sure that this is actually going to solve a lot of the noise problems I've been having at my house. The antenna that I have right now is a wire dipole that the center is up about 30-ish, 25, 30 feet-ish, somewhere around there. And then the ends slope down to closer to like 10 or 15 feet. And it's right on top of my roof, just a few feet above the roof line. It picks up all kinds of electrical noise, but it's good for 80, 40, and 30 meters right now. It's a fan dipole, and it was the subject of a different video that I did talking about the construction of fan dipoles, so you can go see that video also on my channel. Today I'm working on a different antenna. I want to work on a directional antenna. I want something that will actually give me some directivity and be rotatable and have some nulls and some front to back ratio that will make it a little bit more advantageous. Hopefully lower noise, because that's really the biggest problem I have here is the noise floor. There's so much noise in the neighborhood. I want to get away from that. And so my intent is to make a directional antenna and one that I can rotate to null out noise sources, and also to try and get it a little bit higher off the ground to hopefully get away from some of the noise, like physically get away from the noise sources in the neighborhood. I want something that's inexpensive to build, easy to build, and something that I can put up and take down. And so what I've decided on is a Moxon. A Moxon is basically a 2-element beam, but with the tips, like the driven element is up here, and the tips of the driven element kind of bend down toward the reflector, and then the reflector is down here and its tips kind of bend forward toward the driven element. And so what you end up with is a rectangle. I can't do the other half because my hand is holding the phone, but you end up with this giant rectangle of wire. And they're pretty simple to make, pretty lightweight, and I can put one up pretty quickly and easily. So that's what I'm going to be doing. And next I will show you all the parts I'm using. All right, so here are the parts for my Moxon antenna on my wonderful workbench that is my hot tub. So I'm going to be careful not to poke any holes in it. But the Moxon antenna, you end up having kind of a X-shaped support in the middle, and one of the common ways of doing that is to getting an inexpensive plastic cutting board like this one here, and then drilling the holes in it and attaching the spreaders to it. The spreaders, I'm using what are called colloquially known as crappy poles. These are fiberglass fishing poles that you can get on places like eBay and whatever else, but they're telescoping poles, and you can see that they get quite long. These are, I think, about 12 feet long when fully extended. I may not actually be able to get all 20 meters out of that. I don't know. I might have to cut this down to like a 17 or an 18 or a 15 meter antenna. I don't know yet, but I got 4 of those, and those are going to be the spreaders, the part that stick out in the X on the cutting board. Then I've got these fiberglass poles. These are just fiberglass garden poles. They're 8 feet long, and they're going to go straight back to support the back of the middle of the back radiator, and then straight forward to support the balun on the front at the feed point of the driven element. And these fiberglass poles come in these little fabric bags, which is kind of interesting. I'm surprised they spend that much money for packaging on them when you buy them from China, like I did on eBay. And then we got our tools over here. I'm going to use hose clamps to clamp the fiberglass poles to the cutting board. So I'm going to be drilling holes, cutting slots in the cutting board to put the hose clamps through, and then sliding the poles through the hose clamps that are on the board, and that's just going to hold it firm down on the board. So I got 12 of these because I'm going to have 2 per radiating element, radiating from that board anyway. So 4 for the X, and then the one in the front and the center. So it's going to be kind of this hexagonal pattern. And then tools, right? I got drill, got a spare battery for the drill, got my socket set for working the hose clamps, And then I've got a saw and hole cutters because I intend to put the mast up through the center of the cutting board. I haven't figured out exactly how I'm going to attach the mast to the cutting board, probably with some L bracket that'll, you know, clamp onto the mast onto to the vertical part of the L bracket, and then go horizontal and like bolt onto the cutting board. And then screwdrivers, because, you know, you always need screwdrivers. One other tool that I have out here that is not currently on the hot tub is my keyhole saw, which is over there because it's very pokey and I don't want it accidentally poking a hole in the top of my hot tub. And then this is the other bit that I have. So this is a super crappy, what is it, Antenna Master or Channel Master? Channel Master, that's the name of it. Lightweight TV antenna rotator. I got it for 40 bucks at a flea market with the controller. No wire though, so I bought some wire on eBay the other day. It was cheap and easy and available. It will probably do fine for a single band Moxon because this whole thing isn't going to be very heavy. And if it's not, then I can upgrade it later and it's no big loss. But you'll notice that I also have a 1-inch piece of schedule thick. What is that, schedule 40? I can't remember. Anyway, PVC pipe in here. And yeah, schedule 40, there it is, I see it. Right, oh, come on. Schedule 40, right there. Anyway, so that's going to be the mast between the rotator and the antenna itself. Those are the parts. Let's get to assembling. So I am figuring out how I'm going to measure the angles that those cross beams need to be at. And I was thinking about trigonometry, and I was looking for a protractor, and then I realized that there's a much easier way of doing it. And let me show you now. All right, so that's my cutting board. Because I am my own cameraman, I can't show you what I'm doing while I'm doing it because I kind of need two hands to do this. But what I did is I found the center of the board by taking a straight edge and going from corner to corner, drawing a line, going zip, then going to the other corner to corner. Can't do that with one hand. Drawing another line like that, and you can still see those lines are there and kind of rubbed out. So that is how I found the center of the board. Then from that center, because it's a right angle, what I did is I right angled here, drew a cross, and I did the measurements, or I've found the measurements online of the size of the rectangle that the antenna is going to be. And it's going to be 17.993 feet on the short side, and then 46 by, or 0.426 on the long side. And so if you do 46.426 divided by 17.993, and that comes out to darn close to 2.5, or it's 2.4 or something. I don't remember the exact number. I have it in the calculator. And so that means for every inch I go this way, I need to go 2.4 mumble inches this way. And I figured it out that if I measured 3 inches this way, then it ends up being like 7 3/4 of an inch this way. And according to my calculator, those are the numbers. And so what I did is I just used my square and counted out 3 inches this way and 3 inches that way. Then used the square this direction and counted out 7 3/4 inches. And I made these little tick marks here, 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 and here. And so that's the same ratio of the whole antenna. And that way, if I draw a line from the center mark to that tick mark, that is the line that the poles need to go on to be able to spread out the wires. So that's how I drew those lines. I don't have to measure any numbers. I think it's about 42 degrees, if I remember correctly, but it doesn't matter because I've got the exact value, or darn close to it, close enough to the precision of my pencil and my straight edge and everything, drawn on the board now. So now I'm going to do a far less precise measurement, or far less precise activity, there we go, where I'm going to cut the slots in here for the pipe, the hose clamps. And then I'm also going to be cutting a hole right here for the mast to go through. I do kind of want the mast to go all the way through because I think I want the mast sticking up. Excuse me. sticking up from this spreader right here so that I can tie some like guy ropes down from the part that sticks up here and go down to the corners of the antenna and hold them up, kind of just guy the whole thing up, support it, keep it from drooping quite so much, So that's what I'm doing next. Here we go. Really, bird? Huh. I don't know if you can hear the bird across the way. Anyway. All right, so I wanted to stop and show you what I'm doing with these hose clamps. I'm not sure how well this is going to work, but this is the idea. I got one of them in, and it was kind of a pain in the butt to get in there, and I don't know how well it's going to be able to cinch down on that. I don't want it to cinch too hard on the fiberglass because I don't want to snap it. But that's the idea, is the fiberglass pole is going to go in here, and then we can clamp it down with the hose clamp on the bottom of the board here. That's the theory, and this is how I'm making the slots because I'm lazy. I just drill 3 holes in it and then go in and do the thing you're never supposed to do with the drill bit and pull it sideways to just kind of make that into a slot. I do have 1/4 inch end mills that I could use for this, but I'm lazy, so I'm not, and they're cheap drill bits and they're easy to replace. So that's what I'm doing to put the masts on. Let me go finish drilling these holes and see how it does. All right, here's a sneak peek with all the slots drilled and then routed out. Next up is I'm gonna do some similar slots for the balun support that way, and then the reflector support this way. That's what's next. All right, so this is kind of a intermediate step. I'm showing how I've got the pipe clamps put in through the slots on the board. It's not super trivial to do that, so I wanted to give a video of how to do that. So what I've done is I've taken a hose clamp and completely disengaged it. So I've got a whole bunch of them over there that are completely disengaged. And you kind of straighten out the strap part of it, stick it through one slot, bend it over, and then stick it back through the other slot. You kind of have to not be afraid to bend and finagle these a little bit. And then you kind of had to straighten this out to get it through the slots, but then once it's straight, you can't get it back in there. So I ended up kind of bending the tip of these with my Leatherman a little bit. And once you get it in, of course I'm trying to do this with one hand. Again, I am my own cameraman. Once you're able to get it in there just a little tiny bit and then come in on this side with the nut driver, you can usually grab it and get it clamped down. You only have to get it clamped down just a... That's on the wrong side. Haha. I'll fix that before putting that in. You only need to get it clamped down just a little tiny bit to hold it in place. And then once you get them all in place, you'll be able to put the fiberglass rods in there and then screw them down. When you do screw them down, you don't want them to be too tight because you don't want to break the fiberglass. Oh, that's the other thing. Hose clamps. Why are they always flathead? I hate hose clamps. I despise hose clamps with a fiery passion. At least I used to, until I learned about nut drivers. Of course, I've known about nut drivers since I was a kid, but still, nut drivers. What is this? 5/16 for these particular hose clamps. You get the proper size nut driver, and these things are a breeze. A heck of a lot easier to deal with than a flathead screwdriver. So let me get this one turned around so that it's on the correct side, and then I'll try and show you a little bit better view. All right, so see how that tip is bent over like that? That is so that I can get it into that slot right there. See if I can do this one-handed. I doubt I can, but kind of get it in there, and then there we go. I did it. Then you start turning with the nut driver, and it will grab it, and all of the bends and misshapes and everything like that will come out. It's flexible enough that it will bend as it needs to. So you do that for all of the hose clamps. Okay, so the board has all of the hose clamps mounted on it, and you can hear my chickens. The board has all of the hose clamps mounted on it. One thing I wanted to point out is when inserting the hose clamps, make sure you pay attention to which direction the screw head is facing. You kind of want it to be facing in such a way that it's easy to get to, and that doesn't have too much board going across. So like for these on the outside, I had them pointing toward the outside edge so that there's very little that you have to get across to get to them. Whereas those on the inside if I had them facing the same direction, then they'd be getting right in each other's way. So I went ahead and had them face the other direction. These, it didn't really matter all that much because they're all kind of, you know, out in the open. So I just had them facing an arbitrary way, but they're facing all in the same direction so that they'll at least be easy to get to from the same side. And then those, again, I had those facing outside, and then those facing outside as well. So pay attention to that when you are inserting your hose clamps so that you will thank yourself later when it comes time to crank all of these down. Speaking of which, it's time to crank some of these down. All right, so the crappy poles are clamped down. I didn't do a very good job of clamping them in an even spot though, so that one's going to move out just a little tiny bit. And then I am now realizing just how redonkulously large this antenna is going to be, because these 8-foot pieces of fiberglass garden rod don't fit in my current workspace. So I'll be inserting these when I get the rest of this structure mounted on a mast and on a temporary mast. So that's not even the long arm. That is the arm that supports the middle section. These fiberglass masts are going to stick out 12 feet, 12 and a half feet, almost 13 feet in each of those corners, at least for a 20-meter Moxon. And then if I remember correctly, that dimension, that one right there, needs to be 9 feet. This is an 8-foot pole, so the Moxon may be a little pinched in the middle. Well, that's where I'm at right now. I think I'm going to take a quick break and go get some lunch, but then the next thing to do is to drill a hole in there and figure out how I'm going to put this on top of that mast right there. So, all right, be back. Okay, so, that white balance is kind of rubbish. I don't know if I'm going to be able to point things out. It's after lunch, and it is much later in the day. The spot where I was working up there by the hot tub is now completely in the sun, as is my background here. And you can see, so am I. Hey, good, that fixed the white balance. Okay, so we have made some changes to things. First off, I found out that I was looking at the wrong dimensions for the extender rods for the Moxon antenna. I was looking at a tab on my browser that had 40-meter Moxon dimensions opened up. That's why I was talking about like 46 feet and 18 feet, and I'm like, that seems really large, because that was a 40-meter Moxon. The 20-meter Moxon, luckily the dimensions, or the relative dimensions, are the same. So the ratio that I used to calculate, or to draw the lines on the cutting board did not change. But it does mean I do not need 9-foot long separator rods. I only need 5-foot long separator rods, about 4.5 feet actually. So I went back to the hardware store and bought some smaller, lighter weight 5-foot rods. But I was in the process of returning the bigger, thicker 8-foot rods, and I realized that fiberglass pole is stiffer than the 1-inch or 1 1/4 inch PVC that I was planning on using as the mast. So I've actually got that one rigged up as a mast. So you can see kind of in the rotator down here on the ground, the mast is currently going up through my little tripod antenna push-up thingy, and then it goes up 8 feet up there. What I'm going to do is I'm going to drill a hole in my Moxon cutting board. So there it is. One of the fiberglass poles has been extended. The other 3 are mounted but not extended yet. What I'm going to do is I'm going to drill a hole in there big enough to fit over this fiberglass mast, and then I'm going to rig up some brackets with U-bolts and some sheet aluminum that I'm going to bend into kind of a, like maybe a 6-inch piece that with a couple of U-bolts on it that's going to attach to this, and then it's going to bend over, and then I've got a couple of bolts that go through the cutting board and attach to that. And I may do one on the bottom and one on the top so that it's just got plenty of give and plenty of grab there. I've got a cat playing with the with my Moxon. Everyone meet Sabine. That's Sabine being really cute. So, yeah, let's go do that. All right, so I'm in the garage now. This is actually the first time I think I've brought you into the garage before, but I am making the bracket. So I don't know how well you can see this, but there are a couple of little holes tapped in there with a nail and a hammer, just to kind of give them a little starter holes. And then I got, oh, I guess I haven't put any on that side yet, but this line over here by my pinky is where I'm going to try and bend this into an L shape. This is just a piece of 2-inch aluminum stock that I got at the hardware store, and then cut off a, you know, whatever, 8 inches or whatever that is, using a Dremel tool to just kind of chop it right off. And I kind of marked those holes with a nail using the U-bolts that I bought as a template of where to put them. And then I'm going to go to my drill press and put some holes in this. So we'll see what it's like, and then I'm going to try and bend it over at that line right there and turn it into a kind of an L-shaped bracket for mounting the cutting board onto the mast. Let's see how well that works. It's definitely not the prettiest metal working I've done, but I've got this small chunk of rail turned anvil that I was able to clamp the aluminum bracket down. It did bend a little bit there with the clamping, but I was able to clamp that down, and then I used a sledgehammer and a piece of wood. So I just kind of held the wood up. You know, it was originally like this, and then hit the top of the wood with the sledge and just kind of bent it down over the corner of this piece of rail here. Let's see how it turned out. Here. Oh, that's tightening. Not very good, but I can probably hammer that out. But that 90 isn't too bad. Yeah, definitely not the prettiest piece of metalworking I've ever done, but I bet once I clamp that to the pole, it'll work out okay. There's my bracket. So, oops. That top part of the L, this part up here, is too long. Watch this. That bumps up against that. Doesn't go. It's too long. Dag nabbit. So I can cut that end off pretty easily, but moving these holes closer to that might be a little hard. I might be able to drill some holes pretty darn close to it and then just kind of cut it off right at that edge, or through those holes, and make it nice and short. And basically like that. That kind of might be what I have to do. All right, so my antenna should have had a V8. It's a little bent. I think that is ultimately the fault. Oh, stop rocking around. I think it's ultimately the fault of the bend I made on that bracket up there, not being quite right angle. But it's up, sort of. It's a little cattywampus, but there's my mast, still being held up by the little tripod there. And that's probably a little bit high for me being able to work on it comfortably. That's right at my head level, but I think I can wrangle that. And then extend those out to get the wire on it. And that will, yeah, I think this will be a good enough spot to test it. I got a crap ton of weeds out there that might need to go away before I can put this up and really test it, but you know, making progress. All right, it's getting later. Sun's coming down on the other side of the world over there. And I've got some wire. So all of the structure is done, and now it's time to cut out lengths of the wire. I have a Ballon. It's a 1-to-1 current Ballon that I got as a kit from a flea market for about $5. Normally I think they're about $10 each, but and if you get them commercially, they're more than that. But this is a little air core 1-to-1 current balun. If I remember, I will put a link to the folks who make this kit in the show notes down below. But it's a very simple balun. You know, it's got the little hangy thing up there, and then these two, well, I could have done them electrically, but I didn't. So these are just mechanical. And then you got the two wires coming out the side, but it's got a coax coming in the bottom there. So that's going to be the current balun that I stick at the feed point of the antenna. The calculations, doing it for the correct frequency, 14.2 megahertz. It looks like the driven element has two sections that are 15 feet and 4 and some change inches, and then the reflector ends up being 33 feet and 5.8 inches or something like that. I'm going from memory. But what I did is I cut two pieces of wire, well, three pieces of wire. So this is my reflector over here. It's about 38 feet long, plenty of length. And then these are going to be the driven element. They're about 16 or 17 feet long. The idea being that I've just given myself plenty of extra wire for loops and cutting and measuring and whatnot, right? Because I got to loop the wires through these eye holes and then solder them to this. So we've got some wire connections to do. This I'm going to do on the inside of the house. I don't have to do it out here, but I measured it out with, let's see if I can find it. Yep, there it is. My big old long 30 some odd foot tape measure, or 50 foot tape measure. So that's what I did to do the bulk cuts. I'm going to tie up one end of each of the wires, then measure more precisely, because the Moxon does need to be a pretty precise measurement. I'm going to tie up one end, measure precisely, and then very carefully bend and make sure that I cut, or not cut, but that I bend over, you know, loop over the wire at the right distance when I end up doing the final, you know, the second end of each of the wires. And then I've also got to put some spacers. So the Moxon, if you haven't actually seen the design, is kind of a, you know, two U's. One, the reflector is a U-shaped pointing that way, and then the driven element is a U-shaped pointing that way. And then they are connected by a couple of spacers between the tips. The space there, the distance between the two tips is very critical, and the length of the wires is pretty critical to the actual design of the antenna. So I need to make sure that I get all of that right. And that's what I will be doing next, probably inside the house. This is my daughter.
Hi.
She wanted to come out and help. Smoothie break. All right, so I am inside where I've got my soldering iron. I'm going to be putting together the wire bits for the antenna. Really quickly, on the wire I'm using, it is a super antenna model MS-135. It's basically 135 feet of 18 gauge Teflon coated wire. It is super flexible. Super lightweight, black, so it's hard to see. It's good to hide up in the sky, and it's a lot of individual strands. I didn't count them, but it's a lot in there. And so this is one of the pieces of wire that I cut outside. This is one of the director elements that I'm going to be soldering to my balun. And I just wanted to come inside and do it here, where I've got my soldering iron and fun things like that. But so I have gross cut, you know, kind of done a rough cut on the wire, made it about a foot too long intentionally, so that I can do one side of the wire, then measure it precisely, and then terminate the other side of the wire at the right spot and get it all looped up correctly. So for the driven element, I'm going to make the easy, you know, don't worry about cutting length solder job on the balun in the middle, and then I will go measure precisely for the ends that get looped around onto the insulator between the front and the back end. So that's what I'm going to do now. Well, as you can tell from the new t-shirt, it is the next day. Went out to dinner last night and got invited to be on a podcast last minute because one of the normal hosts was not feeling well. Get better, George. And that will drop on Tuesday this coming week. So enjoy that. Ham radio workbench, by the way. So since then, I have made the spacers. So one of the critical dimensions in a Moxon antenna is the space between the ends of the driven element that have folded back and the reflector element that have folded forward. And the space between those tips is critical. So the way I'm doing that is by using my favorite wire spacer, which is PVC pipe, and just have a couple of holes drilled in it, and I'm going to use those for you know, feed the wire through it. And I've got 2 of those, one for either side. Those were measured to pretty precise, within 1/8 of an inch or so distance between those. It was 6 7/8 of an inch. 6.888 was the number that was calculated, and that's close enough to 6.875, at least for the precision of my drills and drill press and whatnot. So last night, I think I can't remember whether I showed this to you or not. I got my ballon, and I have the 2 different sides of the wire soldered to the ballon. So as long as you do one side of a given wire, you know, roughly, and then you measure precisely before you do the other side of the wire, you're in good shape. So this one, I've got the ballon and the 2 pieces of wire hanging off of it. Each of these wires, I think, is about 1 foot extra long, so I can measure it precisely and fold it back over on the insulators. And then I also have a long wire that doesn't have anything on it yet. This is going to be the reflector. So what I'm going to do is I'm going to put the insulator on one end of this in a rough measurement. Then I have to go outside with the big long measuring tape and measure all of the second ends of each wire, all 3 wires, to some precision. And then I'm going to come in here and solder all of that up. When I'm done, I should have a loop with a ballon in the middle, then 2 pieces of wire coming out of the ballon into 2 spreaders, the separators, and then the reflector connecting the 2 separators. So it should just be a giant loop, and that is what I will mount to the physical structure of the Moxon. So let's get going on that. All right, everything's wired up. I got the ballon with all the wires coming off of that. I'm hoping I got the right wires in the right spot, but each of my spreaders, I have the wires wrapped around and then soldered, and I did all of that soldering on the inside of the house and with my good soldering iron. It was kind of interesting how to make sure that you get that measured right. What I did is I took the wire and kind of bent it like that, you know, kind of made a small crease in it right at the precise measurement point. And then I came along and clipped one side, let's say right about there, with just enough to make sure that this would give me plenty of wire to go through the hole and around and twist it. And then I took my wire strippers and stripped the other side just a little tiny bit, just made a little mark there where that one lined up, so that I have a symmetric amount of stripped wire on you know, on either side of the perfect spot there. And so I ended up stripping all of that wire, and I had all of this exposed, or stripping all of that insulation. I had all of this exposed wire there that the halfway point of the exposed wire is the center point, you know, the point that you're trying to measure with. I then put it through the holes of the insulators, wrapped it around, lined them up here, and then twisted the insulator. So the halfway point, or the precise measurement point, is right in the middle of this insulator there, because I have just as much on this side as I have on this side. I lined up the tip of the wire with the where the insulation stops over here, and I just twisted this, and it twisted all of that up there, and then I soldered it, and that was in spot. The Moxon has some pretty precise measurements, and this whole loop here, I don't know how precise that is. Do I measure a straight line from this to the center there, or do I measure as if this thing were pulled out straight? I don't know, but we're talking in the difference of a 1/4 inch to maybe a 1/2 inch, and the measurements the calculations are 3 digits of precision, which is kind of ridiculous. It's nowhere. I'm not doing anything anywhere near that precise. So I'm hoping that this is going to be good enough. At 20 meters, it probably will be. Those kinds of precisions get more critical as you get higher in frequency. So 20 meters being off by 1/4 or 1/2 of an inch should still be pretty good. Similarly with the ballon, I didn't really know where to measure it. So these eye hooks are electrically inert. The signal comes in down these wires with little drip loops on them into the ballon on the inside. So not knowing exactly how to measure it, I just picked the center spot of the balun and measured straight out. And I'm going to wave my hands at whether that's precise enough for what we're doing. So the next thing is to go attach this to the physical structure and see whether my poles are long enough and hopefully have a Moxon up. So this is the first time I've gotten the structure all stretched out. Wow, that's the sun, isn't it? It's the first time I've gotten the structure all stretched out. This antenna is going to be pretty large, and this is the 20 meter. As much as I would love to have a 40 meter directional antenna, I'm pretty sure it's not going to happen. Yeah, this is going to be interesting. So I got the balun mounted here, and it's kind of droopy, but you know, there we go. There's the non-droop point. Fun stuff. Anyway, that's why the mast sticks up a little bit there. Eventually I'm gonna drill some holes in the top of that mast and put some support wires in there to hold this up. And probably the tips of the fiberglass poles as well, because those get pretty droopy on the ends as well. Let's see here. So that doesn't take much to pull down, and it's the last little tip bit that pulls down the most because it's the thinnest of the fiberglass rods. So we'll see how this does. All right, time to go string some wire. So that's a little droopy. I don't know if you can see it with the barbecue in the background, but that is very, very droopy. Yeah, not sure how I'm gonna handle this one. That's gonna be interesting. I think tying off to the top of the mast is gonna be my best bet. I'm gonna have to go out and get some heavy-duty fishing line to make this work. I also am worried that I'm pretty sure these poles are not long enough, so I may have to hold off on the rest of this until my new longer poles show up, or either cut down these wires or make a second loop for something shorter, like 15 meters. That would probably also work, or that would definitely also work. But first, I think I'm going to go to the hardware store and get some fishing line to tie these corners off to the top of the mast. Like that balun is awfully droopy as well, so I want to get that tied up. So that's next. All right, so a few hours later, gone out to lunch with the family, went to the sporting goods store, got some fishing line, 65-pound fishing line that'll do a fine job of holding that droopy balun up to the top of that pole, and those droopy fiberglass lines out as well. Having said that, I have not had a chance to actually redo. Geez, I'm trying to get out of the sun. Sorry. I have not had a chance to redo the balun and make a 15-meter loop instead of a 20-meter loop yet. So there's also the philosophy of just do it on the same balun as the 20-meter and then end up making a dual band. Maybe I'll do that. That way I don't have to spend the time of making another balun, because that was not, it wasn't complex, but it also wasn't super short. So anyway, I'm gonna try doing this. I got my drill out. I'm gonna drill a hole at the top of the mast right there, and run a line down from the top of the mast down to the balun right there. I mentioned I'm my own cameraman. This is kind of awkward. So I'm gonna go do that. I'll be back in a bit. So the balun's a lot less droopy now. It's still, I probably could have tied that rope a little bit tighter, but let's see here if you can actually see it on the video. This is the string. Anyway, it's not going doing, at least you can't hear it over the chickens. So holding that up, tied a granny knot around the balun here, but it's getting the job done, and that goes up to the top pole, which is maybe tilting a little bit, but not too bad. And once I start tying off some of the other ends, it'll sag a lot less. I haven't done any of the fiberglass poles. I'm realizing that I can't put a 15-meter on the same balun as the 20 meter and use these poles, because then the 20 meter wires will still be there and they're not supported. So doing that when I get the long poles in place is something that I could do, but I can't do it with these. So if I'm going to make a 15 meter loop for these poles, then I need to build another balun for that. And I'm kind of thinking at this point that I don't want to bother with that because the long poles will be here soon. They're on a slow boat from China, so whenever they get here, they get here. Hi, bird. So I think basically what I'm saying is I think the project is done for this weekend. I have proven out the concept. I've gotten the spreader kind of, you know, center support done. I've got my mast. I've got my rotator down there on the ground. I've got the concepts with the poles, even if these poles are a little droopy dog. Yeah, that's a good shot. Shows you just how droopy they are. You know, so it's an antenna in the making. I was not able to get on the air the first weekend, but we'll do better once the long poles come in. I kind of don't want to bother with a 15 meter right now. I don't know why. I'm lazy, and it's 4:30 in the afternoon. I've probably got another couple of hours of sunlight, and I'm getting tired, honestly. So I think this is going to be the wrap up of this particular video. I will come back next weekend when I put up the mast, because that is going to be an entire project of its own, kind of separate from this antenna. I'm doing them at the same time, but they're kind of two different projects. And then once the longer poles come in, I will start this one back up, do a part 2 on this video, and see what the Moxon looks like with 20 meter pole, you know, length poles, and the loop of wire and everything else that we've got going. So hopefully, I don't know how long that's going to take. These poles took forever to show up. I must have ordered them right after the last slow boat left, and then they had to wait for the next slow boat to leave. So I'm not sure how long these poles, the new longer poles, are going to take. But when they get here, we'll play and build an antenna. So anyway, I think that's it for now. Thanks for watching. Hopefully this gave you some motivation and incentive to start building antennas, start playing around, seeing what you can do. You know, I'll put some links in the show notes for these crappy poles. Yeah, let me know what you do. Let me know if you're having a good time, if you enjoyed this video. Subscribe if you want down here. You can also follow me on Twitter, SmittyHalibut, same username that I have here on YouTube. And yeah, tell me what you think. Thank you so much for watching, and be good humans. 73.